This lesson is over proportional versus non-proportional relationships. And so we've been working on that this week. We have been using tables, graphs, and equations to figure out our slope. We just have input-output charts here, guys. An input-output chart, you tell me how you get from this side to this side. And please remember that you have to multiply. You can't be adding and subtracting from one side to the other. So I don't specifically know in my head how to get from 12 to 8. If you don't know how to get there, you put your y over your x. Now, please remember, we talked about in 6th grade science, you guys using dry mix. So where you found your dependent and your independent to figure out which one was your y and which one was your x. You have to have toys to sell before you can sell a stuffed animal. Because of that, stuffed animals sold depends on how many toys you actually sell. That's your independent. Because this one's with a D, this one has to be my dry, this is my mix, which means this is the x-axis and this is the y-axis. So now I can go ahead and put my y over my x. As soon as I do that, I get 8 over 12, 36 over 54, 68 over 102, and so on and so on. Once you have that, put it in your Desmos calculator and divide, guys. Just figure out what that is. You can write it as a fraction, which in this case would be 2/3, or you could write it as a decimal, which is 0.067, if you would like. Either way is fine with me. When you're doing this and you're going times 2/3, even input your stuff to check it out, because your equation would be x times 2/3, because that's what you're doing, should equal y. Put that x value in there, substitute it out to see. So like 2/3 times 12 is 24 over 3, which is 8. And so that's what I got. Make sure that it actually works when you put it in there. So my slope is 2/3. My slope is 2/3. And you can tell from this equation right here, this is where you find your slope. If I'm looking at this equation here, there my slope is. I love equations because it just gives you the answer. Your graph is another story. You need to find a point that is plotted somewhere where you don't have to guess where it's at. For example, this dot here is plotted on intersecting lines. It's on the line. I don't have to guess. So this ordered pair is 50 over 30. So if I do my slope, y over x, that is 30 over 50, or 3/5. My slope is 3/5. Knowing what I know about equations from this question and this question, this line's equation is y equals 3/5 x. Your slope just goes in front of the x. So we said that proportional relationships have that constant rate of change. What they do from one side, they do to the other. They make a straight line, because if on the y-axis you're going up 1 and on the x-axis you're going over 3, you're literally going up 1 over 3, up 1 over 3. When you connect the dots, it should make a straight line. And they all pass through the origin. Guys, if you didn't have any toys to sell, you couldn't sell a stuffed animal. If I went back to my equation and put it x as 0, so I substituted that out, I would get 0, 0, 0. So those are all proportional relationships, must have all of the following things. The one on the left, while it passes through 0, 0, is not proportional because it's not a straight line. The question on the right, this is proportional because you do have a constant rate of change. You're sitting there, or a constant of proportionality. You're multiplying by 2 the whole time. And if I inputted 0, 0 times 2 is 0. So I do have 0, 0. So looking at Jamie and Dante's tables, guys, it's an input-output chart. If you know how to get from here to here, you don't have to do any division. Just put that number there. Whatever that number is happens to be the slope. So I know 5 times 8 is 40. I know 9 times 8 is 72. I could figure out 15 by 8. If you don't know how to do that one in your head, Desmos calculator all day. But this is times 8. So when you're doing this, hours worked times 8 equals the money. right? So that would be my equation for that one. Dante, on the other hand, I'll tell you, I don't know his in my head. So I would need the y over the x to divide it. Guys, if you don't work, you shouldn't make any money. The money you make depends on how much you work. So this is the dependent over here, which is going to be dry. This one's my y. This one's my x. Let me make the y a little better. So this one would be 106 over 8, which if I put it in my calculator, it looks like this. This one's 120 over 10, which if I put it in my calculator, it looks like 12. Dante's is not proportional because it didn't divide out to be the same thing. It's not a constant, okay? Not a constant. It doesn't have the same slope. So when I go look at these two as graphs here, I see there are both of their graphs. I know whose is whose. I know Jamie's is the proportional one, so hers must pass through the 0, 0, and Dante's is not proportional, so his doesn't pass through 0, 0, even though it's a straight line. With that being said, I will also say what we are going to do right now is figure out how did they tell me that Dante's line passed through 50? Because if you look at this table, I don't see where Dante has $50. Like, it passes through 50. That 50 is total amount of money he has earned. Not on that table. Where are they getting that from? That's what we're discussing today. Like everything we do in math, most of the stuff can be found on the star chart in case you forget. There's one that says direct variation. Guys, that's your constant of proportionality that you did last year. I told you in class I sound like a thesaurus. They just changed the words so many times. I don't know why. But that's how, if you isolate that k, so y equals kx, if you isolate the k, you get the slope. You get the slope. It's the same thing. Now, the one that we want to look at is right here, the slope of a line, because as you can see, it's still y over x. Where did they get the y2 minus y1, x2 over x1? Well, you guys have done these little 2's and 1's. When you go back to how you learned how to do the area of a trapezoid, it was like area equals base 1 or plus base 2 times height. Like, you've done the 1 and 2 before. It's literally just means that there are two y values or two x values. So let's look, okay? So I'm going to try one that's proportional just so that you can see it first. On this table, I'm telling you this is a proportional table. The reason I know is because if I put regular, my y over my x, it'd be 25 over 10, 40 over 16, 66 over 12. I went and put those in my Desmos calculator. All three of those equal to 2 over 5. So I know that I am multiplying by 2 over 5 to get from one side to the next. But what specifically I want to show you is how to use this formula. So again, where do they get the 2 and where do they get the 1? Literally, they just go number this off. And then they say y2. So y2 is 40. y1 is 25. That's all they're doing. x2 is 16. x1 is 10. And when you put that, when you actually do the problem there, 15 over 6, go put it in the Desmos calculator, and you would get 2.5. No matter which way you do this, you would get the same answer. So it's just a different way to do this. This way is specifically used for problems that are not proportional. So let's go ahead and take a look at that. So here's a problem where I don't know how to get from the left side to the right side, not in my head anyways. So I do know, again, I'm going to need to go ahead and put my y over my x. 9 over 4, 15 over 12, 27 over 28. And I could go put those in the Desmos calculator just to check them out. When you do, you'll find out that you're not going to get the same thing. Guys, if you write this out, you should understand. This one is greater than 1, and this one is less than 1. So greater than 1, less than 1. These are not the same. They don't have the same slope. So we are going to have to use this formula over here. So y2 minus y1, let's go label them. 1, 2. So y2 is 15, y1 is 9. x2 is 12 minus 4. I get 6 over 8, or you can even simplify it to 3/4. They are telling me to multiply x by 3/4 to get y. Let's check that out. So let's go ahead and multiply by 3/4 so that we can see. I'm going to write that on top instead. So times 3/4. So 4 times 3/4 actually happens 12 over 4, which is 3. This is not 3. Like, I just did it and I got 3. I didn't get 6. I'm sorry, I didn't get 9. So when I'm doing it next, just to check, 12 times 3/4 is going to be 9. So I got 9 here. I did not get 15. The next one, 28 over 1 times 3/4. I'm showing you this for a reason, I promise. So when I do this, I would get, when I multiply that, I would get 21. Here is what I want you to notice, because if I do all of these, this one would be 33 and this one would be 27. All of the numbers that you get after you multiply by 3/4 are 6 away. 3 plus 6 is 9. 9 plus 6 is 15. 21 plus 6 is 27. Guys, you are multiplying by 3/4, but then you have to add 6 more to get to your answer. So when you don't have a proportion, we know we don't have a constant rate of change. We know that the equation cannot be just to multiply because we know it's not proportionate. So that can't be my answer. To get there, you have to do a little more than just the slope. You're going to have to figure out what you add or subtract by to get to y. So what I'd like to do is I'd like to go back and look at Dante so that you can see what I'm talking about. Dante, it said his line passed through 50, and I wanted to know why. So I'm going to take his and I'm going to do the formula y2 minus y1 from my star chart. And so y2 is 120, y1 is 106, 10, and 8. So if I do that, I get 14 over 2, which is 7. They are telling me to multiply by 7. Multiply by 7. Well, if I multiply by 7, 8 times 7 is 56. 10 times 7 is 70. Okay, so you would go down here and you would multiply all of these by 7 to figure out what they are. I know this one just in my head is 210. This one right here would be 175, and whatever the other one is. So when you do that, you multiply by 7, you're going to get your number. If these aren't proportionate, you know that you can't just multiply by 7. We did this and it wasn't proportionate. So I cannot just be multiplying by 7. I'm going to have to do something more. Figure out how you get from the number to the next one by adding or subtracting. All of these, you add 50. 56 plus 50 is 106. 70 plus 50 is 120. 210 plus 50 is 260. This would be the equation. Whenever you are looking at something that is not proportionate, please know that you are not just going to have to multiply. You have to do something more. You're going to add or subtract. If you see an equation where it is adding and subtracting, so for example, right here, this one right here, I'm just multiplying. Anything I put in there, it's always just going to go up or down by negative 12. And if I put in 0, it'd be 0, 0, 0. This one is proportionate. Because you have to do something else to this one, it is not proportionate. If I go back, so I knew that this was, I knew that this one right here was times 7 plus 50. So times 7 plus 50. And so even if we go back to our chart, you can see what I'm talking about here. This one right here, we said times 7 plus 50. If you go over here, you can see that he crossed by 50. So I do know where they got the 50 from now. So this is what we are going to be working on.